I'd like to begin asking a question, directly a question. What do you do when something is painful, but you cannot avoid doing it? Exactly, I love you. But some other people think, let's postpone it. Or as you grow into a senior, you can say, let's delegate it, right? But that's not the way you should do it. You know that, just do it, but even more, do it more often. Bring the pain forward. This is the underlying philosophy of extreme programming. You've been to the keynote, right? Extreme programming. Tell me, how does it feel when you work on your own branch and after 2 weeks or 3 weeks of development, you merge with the work of the others? How does it feel? Red, right? Painful. Oh yeah. So what do they say? Do continuous integration. Push every half an hour, every day, as frequent as possible. But then they will call you for a code review. How will it feel? Oh my God, I'm going for a code review. What will they do to you? So then, what do they say? Pair programming. Let another human look at your code right from day one, right from the inception time. Don't wait for the inevitable to happen. Do it more often, right? Then how does it feel when you end up in some code base which was never ever refactored? Ooh, it hurts, right? So what do they say? Continuous refactoring. When you push code to Git, you should be printable and put it as an annex to your CV. This is how I write code. This is the kind of quality you should aim for. And then how does it feel when you go into some code base with 0 unit tests? Oh yeah, oh yeah. So what do they say? Test first. All of these 4 practices are actually a direct result of this philosophy, bring the pain forward. Okay. So, Привет, Moskva. I am Victor Rentea. I am from Romania. I speak Java. I'm a lead architect at IBM, but my work, what I'm really doing is more of a consultant. That's with the picture in the background, right? I'm also a weird guy. I'm practicing these things, pair programmer, refactoring, TDD. I'm practicing these things each day. And I'm also very, very passionate about clean code, and I've talked about it in too many places already. The point of this slide is that I have a website, okay, in which you can find my best talks. I don't have that many ideas, but a selection of the best talks that I ever gave, you can find on my website. Now, 6 years ago, I started training, right? And by now, I already gathered some experience, I'd say. I started like any of us should start, with frameworks. These are easy to learn, easy to teach the other. Easy, do it, coach the others, become a trainer yourself. Then I moved to more high-level, esoteric topics like design patterns, architecture, clean code, unit testing. I'm also into performance in Scala. But the point of this slide is it's not this. It's in the corner. Is that I post daily on these social networks, all of the 3 social networks, things that I learn myself from my trainees, like I had yesterday, from everywhere, from things that I learn and so on. Me gusta hablar. Okay, I've talked to so many people already, and I've heard a lot of issues, so I'd be more than delighted to find your own problems after the talk. Organized the largest 3 Bucharest Java user group meetups in history. The last one last year had 170 people. I also founded my own Bucharest software craftsmanship community. And yes, my friend, this is a feather. That is a feather, because writing good code requires determination as well as a sense of art. Now, in this community, I currently only run activities in Romanian, but I'm running a book reading club weekly and some live coding session free for everyone in the community every month, but currently only in Romania. Let's start. Yes, let's start this stuff. I want to tell you a story, but let's first meet the participants. Who is this guy? Has a big mouth and a tie. It's the boss, it's the customer, yes, the boss. Who is this guy? You know that one, right? The question comes, this guy comes and says he wants to log the methods passed to the method M1. What do? You log debug M1, of course. Then he wants for M2. What do? You are a professional programmer. You copy-paste from that to the new method, of course, and adjust it. But then he wants for these other methods too, and you do the same, of course. You are a professional programmer. But then comes the basis guys loves it so much that it wants for all the methods in that package. Oh my God, what do? Ooh, you copy paste. That's what you've been taught. What? That's what you do. Come on, realize. We're copy pasting code, right? But you feel bad, right? First, the next several minutes, but time passes by. Piva passes by. And as time flows, you forget. And in several weeks, you come back to that place and you want to put a method. What happens? Well, this guy gets angry. Why? Because he found a bug. You forgot to put the log debug in that method. Oh, yes, +1. Then he wants to change the format. And you start adjusting code, right? Everywhere. Well, actually, almost everywhere. There were 110 yesterday. Oops, you missed a spot. And this guy, again, gets angry. You know what this is? This is this. You're scrubbing the floor. You missed a spot. That's what it feels like, right? So, question for you guys. Where is the problem in this slide? Can you figure it out? Hint is in red. Huh? Copy-pasting code would be the capital sin in programming. You don't do that. We even have a principle for that. Don't repeat yourself. Dry. Do you guys know the antonym of dry? We enjoy typing. Or write everything twice. Or even better, duplication is evil. Oh yeah. No matter you spell it, comes the same stuff. You should never copy-paste your own logic with bugs. Do copy-paste from Stack Overflow, but don't spread your own intelligence everywhere. So what you should do instead, you should decompose that code into pieces and then code it in another way to do your new stuff. Now, even if I do that, I still need to add one method to each, one line to each method that I want to basically log, right? And now comes the idea. What if I could magically intercept a method invocations? Oh my God. This, of course, probably most of you know already. This is called aspect-oriented programming and allows us to do cross-cutting concerns like logging, transaction, access control, things I don't want to repeat in all the methods that I want to apply these concerns. Nice. This naturally leads us to the proxy design pattern, which is basically a placeholder. This is a proxy, by the way. This is a proxy, because instead of me sitting here and pressing next, back, I can move around and use my proxy to delegate my interactions to the real subject. So basically, there is a client who wants to talk to a real subject through an interface. Then, somehow, magically, a proxy is being generated, and it's given to the customer instead of the real subject. You know what this is? Tovarищ майор. You call a method to that proxy, and you think you work with the real subject, but instead, your call will get to the proxy, which will do stuff like aspect-oriented programming, or historically, will maybe remote your method invocation over the seas and far away where the actual implementation resides. So remoting, this was the historical reason for proxy to appear. Okay, that's proxy, but then let's see about Decorator. Decorator is pretty much the same stuff. The difference is that Decorator, again, just like the proxy, a decorator will pretend to be the subject, will implement stuff before, after, or instead delegating. But the difference is that they can be nestable. Have you heard of buffered output stream? Huh? Buffered output stream is an output stream, and guess what? It wraps another output stream, exactly this. And compared to proxy, decorators are usually written by hand, okay? Enough talking, right? Let's do some live coding. I will try to demonstrate these stuff. Okay, so let's see. The exercise is very simple. By the way, I use Eclipse. I'm sorry. Okay, so you had your laugh, so we can continue. Now, what I'm doing here, I'm computing the prime numbers, okay? So, oops, I'm calling 2 times the computation is prime for this number. Can you figure out a way to make it more efficient? Of course, let's use some sort of a caching. But in case we would not have any kind of spring in place, what would happen? What would be an option for us? We could say if in cache, then a return from cache, right? What would be the cache in this case? Well, it should be a private static final, just to make Sonar angry, map between integer and Boolean. of course. This is cache equals new hash map of cache, of course. And then what does it mean to be in cache? Well, it means that cache dot contains key of n, for sure, and I will return basically cache dot get for n, just warming up, just warming up. Am I done? What are we still, come on. We did not put anything in the cache, right? So let's fill the cache, of course. Where should I fill the cache? Wherever I return, I should remember what is he doing? He's mixing things up. Take him off the stage, take him out of here. But look what would be one option for you. To copy-paste programming everywhere. And to just place false here, but stop. So come on, this is outrageous. Just stop right there, because what we are really doing, we are violating the single responsibility principle. We are mixing things. We are adding the caching concern to a method which is already complicated. So guess what I will do? I will use a technique from refactoring, which means to duplicate the method signature, hide the old signature under some nice name, and then for the previous signature, simply put there what you want to add to the method. I need then to call the isPrime with money, and I will say this is result, of course. I will put result here, and then I will say return result. And that's it, and I will even run this. Yeah, I will run this. Let's see if I manage to do the job. Let's see if the call for computing isPrime never happens again. It never happens again. Look, this doesn't appear here. You see? So the computation is actually cached. Just warming up, Ooh-ha. So this is one way to do that. But you see, still, if we make more methods like that in this same class, things will get more and more dirty. So we will now apply single responsibility principle on the class level. And we will basically create a new class. Yes, expensive ops with cache. I need to make it static. This is always how I create or how I extract my classes. Right in front of my eyes, I want to have them right next to me. I will say private, final, expensive ops, and then say delegate, then generate a constructor for that field, and then say delegate dot is prime here. Very nice. Then this doesn't, because the name collision is no longer present, I can kill this. I just take this class here, and for my convenience, I will put it in the other application, in the other class, just to have it in one place. And in this moment, I will run. Will it work again? Will it work? What do you think? Yes or no? I've moved the caching into a separate file. Well, something is missing, right? What is missing? We never used that new class. Look, the computation happens twice. Obviously, but then how can we do this? One way to do it is to go and say this is a service managed by Spring, and then just, instead of auto-wiring the expensive ops, the real implementation, to auto-wire the expensive ops with cache. What do you think about that? Well, exactly. What the heck is this? No. But, let me help you. Let me point out where the problem is. This is Zen code. This is holy domain logic. I don't want in this class to appear things, infrastructure, performance, miseries, the caching, don't want that there. So then what can I do? How can I still be able to use the cache without polluting this stuff? What I will do next, look, in the expensive ops, I will extract an interface from this. Name it very wisely E, expensive ops. Okay, professional stuff now. Okay, and then this interface gets extracted here, but as I go to the previous file, I remain puzzled. What the heck happened here? I never touched this place. You know what? The IDE, IntelliJ or Eclipse, they both replace the concrete class with the interface you extracted if all the methods that you used are now in the upper interface by default. Only this refactoring effectively trashed 1/3 of the Gang of 4 book. Because program to interfaces, what the heck? If you need an interface, it takes you 3 seconds to make it. So don't just put interfaces there just to be an interface. Don't do that. Extract interfaces while you need them. Only when you need them. Okay. But then what's next? Well, I want to put this in place, so I need this to also implement expensive ops. For this to implement, I need to add one more method that I did not see yet, I will not cache this one. I will directly delegate hash all files and silently ignore that method. This time, if I run, will it work? Well, I'm requesting the injection of an interface, right? But Spring finds there are 2 implementations for that interface. He will not make this choice for me. So it's my turn. How can I convince him? I can put here primary. That's one way to do it. This time, every time when Spring will have to choose between this implementation and another implementation, it will always choose this one. Make sense? It will effectively always select this one. This will always win. And it works. Look, there is no more computation happening in between. Do you follow? Give me a feedback. Yes or no? Good. Now, let's see. This is one option. Another option, what if I want to control whether I use the cache from exterior when I start the application? I can make it a profile and say with cache. In which case, in case I go and say here that I want to launch this application using with cache, guess what? It will just work. Just if it's compiled, it will be even better. Let's see. OK. So basically, now I am forcing the application to start with the cache. However, if I don't put the flag, if I skip the flag or mess it up somehow, then guess what? The primary bin, which will otherwise win, is not visible because of the profiling in Spring. Oh, there you go. It is computing twice. Do you see that? Look, computing, computing, time, time. OK. So that's one way to do it. But now imagine for a second that you would like that in some places to inject the cached version, and in other places to inject the undecorated. Because, by the way, I don't need to say that, right? This is a decorator. Implements the interface of the subject and adds more logic to its method, effectively the caching mechanism. So what can you do then? You can go and say, let's copy this name of the class. Oh my God. No, don't do that. Don't do that in front of others. There are children here. This will work, but it's ugly. The name of a class appears in a string. Christ, it's ugly. No, stop. So don't do that. Instead of doing that, why not go more type safe? What is the last time you created an annotation? Huh? With cache. OK, this should be retention at runtime. Otherwise, it gets wiped out just like overridden is. And I want to mark it as a qualifier, because guess what? The qualifier annotation from Spring declares, oh my God, who will do such a thing? An annotation that can annotate other annotations. What the heck is this? This is a stereotypical annotation. This is how it's called. You can annotate your own annotation with that. And guess what? On the implementation, you put that. And at the injection point, you decide that you want the variant with the cache. And now if you run by type safe, there are no more name of the beans and nothing, no more strings. Type safe annotations. And if you run, guess what? It works. Yes. So let's commit. This is basically a decorator with many ways of selecting it. OK? Now just commit and push. So it will all be pushed already on a Git. I will show you the Git afterwards if you want. That's the Git, so make a picture. Exactly, that's the point. Thank you, very well. More programming, huh? OK, but then guess what? I will just kill this. Oops, too much. Destroy this, destroy completely the cache. Wipe everything out, just make it clean, right? Clean stuff. I will, for a moment, just not auto-war anymore. So folks, we are stepping out of Spring for a second. And then we will say equals interface proxy, not proxy of new expensive ops. OK, what is this class? This class does not exist yet. Let me create that for you. There you go. And then let's create this method too, that basically will decorate what is called real implem. That's it. OK, then. Are you ready? Are you ready? Let's go. So, proxy. New proxy instance or class loader, interface proxy, interface proxy.class loader. Then comes an array of interfaces. Oh, I love Java. I just love Java. I tell you why I love Java. New class array with values. Yeah. Woohoo. So expensive ops.class. Who the heck is H? We will see in a moment, and I cast this to expensive ops. Have you seen Lord of the Rings, episode 2? Saruman the Grey was spawning golems out of nothing. That's the same thing. I'm spawning an instance of this, implementing this interface out of nothing. I only need to provide the way it should respond to any method invocation. Guess what? I will run the code now. What will happen? Null, null. Someone answered. Who? Tovarăș Major. Someone answered your phone call, right? And said null. Okay, but then let's get real, right? So, let's suppose we want to create a map of a list of objects. This is the key in the map. The value is a generic object, and I will say cache equals new concurrent hash map. Vash out of memory, sir. And then I will say private list, object get cache key of method, and object args, and say list object list is a new array list, then list add the method get name, and then I'll say list add all of arrays as list of args, and then I'll say return list. Thank you. That's it. I've created the way to make such a cache key. Then what will follow? You can figure out, I think, right? It will follow here. Let's try. I need first to create the key, because get cache key of method and args. Simple stuff. And then comes the horror part. I will log debug the intercepted, then say method get name, and then let's see. Return cache.compute if absent of key and uncheck dot function of unused arrow method dot invoke on real implementation comma arg. Thank you, that's it. To make it work, but by the way, some of you have recognized already that I am using Lombok. I'm sorry. Or maybe I'm not, who knows? But the point is that this unchecked function, for those of you who never saw it, if I want to skip that, look what will happen if I put that. Because my method.invoke throws an exception, a checked one. Who would throw a checked exception? Anyway, if I use the IDE-driven development, look what will happen. A try catch, yes, right in the middle of my code. So to avoid that, I use unchecked function, which does effectively exactly the same thing, swallows the exception and throws a runtime instead. Whoa, let's run this code. What will happen? What will happen? Well, let's see. First of all, we see that we've intercepted this prime, and we see that the second time we call this prime, it never gets to the real implementation. Exactly what I wanted. Make sense? This is GDK proxies, right? Spawning objects which implement interfaces out of nothing, just spawning golems. Okay, this we need to commit. Name it, I don't know, interface proxies. Okay, and now I will commit. You know why I will commit, right? Because after I commit, I will take this and delete everything. Delete the proxy. Delete the interface. Why to have an interface for that in the first place? But anyway, then make it no more implements here for me. Good. And then here, no more implements here. And then guess what? Instead of interface proxy, we will now create a class proxy, of course. Huh? Let's make it. So let's create a class proxy. That's it. We notice there is no more interface. This is also called real implem. And then comes the interesting part. Before I used proxy.new, by the way, it is all recorded. When you play this, play it at 75% speed. Good. Now, what do you do here? Look, first, previously I did proxy, new proxy invocation, new proxy instance. Now I will do enhancer from CGLIB. Yeah. Some of you, when you see CGLIB, oh my God, CGLIB. And I'll explain you why they feel that. I need to create the expensive ops.class using a callback. What callback? Well, actually a new method interceptor from CGLIB. Now, I know that we can turn this into a lambda in no second, right? I don't argue with that. We can make it a lambda. But just for the sake of the moment, I don't want that. If you make it a lambda, there is no way you can define a field for that anonymous interface implementation. But then look, I will use paste. Again, C++. Copy-paste programming is with us today. And then I will put here SLF for J. And then guess what? I need to name it method. I need to name it args. And then I will simply shamelessly copy the old implementation in the new one. I need to cast it, and I run. I run, folks. Doesn't work, huh? Let's see. Doesn't work. Object is not an instance of declared class. Free exception, what's that? No. Expensive ops. No. Again, no. Expensive. Not that IntelliJ will figure out, trust me. By the way, I have IntelliJ started in the background in case Eclipse fails me. No, it worked. It never computed the prime anymore. Good, that's good. So I have this class proxy, which allows me effectively to proxy a class. Now, high school question. What kind of object can be assigned in Java to a field of type expensive ops? An instance of expensive ops or of a subtype. Yes, I guess what this is doing. And this is actually one when we will think about Tovarищ. Tovarищ Meyer, who are you? Who am I talking to? Let's run this. And as we learn more, we became less happy. Look. What we thought was expensive, really now, if you never worked with Spring and you came to Spring or any other dependency injection framework, when you see that it wants to auto-wire an expensive ops, you will think that it's a class of that instance. What with an instance of that class, nothing more. OK, good. Now, some of you are thinking about final, yes, that will break. Let's wait for a second. What's next? I did that. Let's push that. So this is what I would say to be the class proxy. And it really worked. That's the interesting part. And now, finally, let's get back to Spring again. So no more playing around. Come on, what the heck? Some of you, or I saw someone leaving. What is he doing? He's writing map.caches. What is he doing? So I'll come back to here. I will auto-wire again. And then I will come very gently and say, is prime? I want this to be. Okay? Shabal, excellent, excellent, very nice job. And the same applies for the other method we never looked at. You never saw anything. OK, so this is folders. OK, so run. One line, one annotation on that method, and I'm done. It never computes the prime again, right? Now is the time for me to uncomment this part and to ask you a philosophical question. I know half of you are in the siesta period now, and half of you are dead hungry, right? Because lunch is, it's unfortunate, but you still need to think. What is the difference between this and this? The fundamental difference, philosophical difference between the two usages of a cache here. Tell me one thing. If a number is prime, will it ever turn not prime tomorrow? No, I say no. This is called memoization in artificial intelligence, or I don't know, game theory. Memoization meaning to remember a truth which will never change in the future. It's the classical trade-off between space and time from computer science 20 years ago when you were in high school or faculty. Okay? So this memoization means to remember something which will never change in the future. But then let's think about what it means to hash MD5 hash of all the files in the current folder. What if I add one more file in the folder? What will happen then? Do any of you know how this code continues? There are only two things hard in programming. Cache invalidation and naming things. And off by one error. So cache invalidation, this is what I'm talking about. What if in between, I want to invalidate the cache? I detect a change, and I want to throw away the cache that I knew for the folder dot. What can I do then? Ooh, let me try this. So I will say ops.invalidate cache for folder. Which folder? This one. This is a new method. I will create a new method, and I will then say here, cache evict. I will evict the entry from the folder's cache corresponding to this file that I'm given as a parameter. Now, as one of my developers from yesterday told me, I should put here a classical comment. Do not touch. Let the magic happen. Why would I ever need a method with no body, with no content? Why? Because the very call of that method will go through the proxy, which will kill the cache entry for that folder. Make sense? Now, what I want to achieve, I want to compute the hash twice, because in between, I must throw away the cache for the folder, and there I am again computing hash all files. Make sense? So I'm computing again. But let me help you a bit. Let me get back here and repeat this call. So as I run, you look at the code, and you will realize I'm calling hash all files 3 times. I'm calling it 3 times, and even though I'm calling it 3 times, it only runs twice. Why twice? Runs here and here. Because this line did not require a new computation because it was taken from the cache. Make sense? So until I invalidate the cache, it will just return the value I've stored previously in the cache. I think I've mentioned the cache word 100 times in the last 3 minutes. I think we should switch this domain, right? Interesting, interesting. I will just push this, and I will say cacheable in Spring plus magic, empty method. Ooh, empty methods which are there only for the proxy to sense them. That's it. Ooh la la, good, good, good. And we are just warming up. We have some more stuff to do. So let's now create a custom aspect. Oh my God, what's that? So just as cacheable, we can use the Spring AOP infrastructure to create our own aspect. It starts like that. In a distant file buried underneath 10 foreign packages sits this component, which is here for JAspect, which is class myAspect. This contains an annotation saying that he wants to intercept around the execution of a method, any kind name of the method, returning anything with any kind of parameters that just happens to be within a class which is annotated with facade. Good. Now comes the fun part. Public object execute around the proceeding join point throwable, and then say log debug, and then call intercepted. Oh yes, join point.get signature get method, and then raise to string of join point.arg. Thank you. And then return join point.proceed. Yes, that's it. Whew. And now let's see how this works. Well. What am I doing here? I'm saying that I want to intercept any method invocation from a class which is annotated with this annotation. What annotation? We'll create that. Guess what? Interface. This is facade, which should be retention at runtime. And then this should be applicable only to types. And I think that's it for now. I will put facade on my expensive ops up above here. I will just say at facade. It is my own annotation. I will run this. And now guess what happens? Because the 2 methods below are within a class which is annotated with facade, guess what? Call intercepted. Once, twice, thrice. Aha, okay. Okay, so I'm intercepting a call from somewhere just because the method is in the class, which is okay, I can live with that. But still, if you are looking in the expensive ops class and you are at line 563, as usual, you might not be aware that the class you are in is actually annotated with facade. So what I would like to do next is to bring closer to the method this annotation. But before I do that, I will just silently do something. I won't explain anything. I will just run it. Shh. So again. Mm-hmm. Mm. Hmm. Mm. Hmm. Mm. Hmm. Mm. Stereotypical annotation. Spring will figure out this. So service is a component. Guess what? A REST controller is a component. So now facade is a component. I call this layer annotations, actually. Nice. And guess what you can do here? I won't do that, but just sketching my production code. Transactional. I don't even have this dependency. Transactional requires new. Nicely done, right? Transaction boundaries at the facade level. You call it application service. OK, application service, that level. Good, but then let's resume. I want to have this annotation closer to the method I want to intercept. So let's put here logged. Now, what is this logged? Have you ever heard of that? No, because it does not exist. So let's create it. I will just create the logged annotation. I will say it can be applied to methods. I will then say that I'm not anymore intercepting methods within a class, but I'm intercepting methods that have the annotation logged. And now guess what? I applied logged only to one method. Remember, only to isPrimes. And look at the log right now. Call intercepted here. But if you look down at the second method, it is not intercepted, right? Aha, aha. So now, this is actually probably the best way of working with aspects. By placing annotations, by weaving aspects, by intercepting methods, when you annotate the method with some annotation of your own. You have finer grain control, and it is in front of the eyes of the developer. Doesn't need to be aware that it is somewhere. Okay, it's just there, logged. What the heck is logged? Ah, it intercepts my method. Get the point? Yeah? Yes or no? Give me a sign like in Gladiator. Yes or no? Yes. Good. Now, let's move on. Woohoo. Now is the time to show you some tricks. Yes, it's time to show you some tricks. First trick. How would you know? Basically, it all starts with looking here. Oops. Looking here. Why was the call intercepted printed here, but not here? How can I make it simpler for you? I call isPrime two times. The first time, it is not cached at all. It actually runs, but it is also printed in the console. The second time I run, it is not executed, but neither intercepted by my own aspect, which brings the question, why not? Now, I will show you how to debug this situation. Have you ever created a new runtime exception and never throw that? Do you know Chris de Burgh, Lady in Red? Please don't panic. It's an exception, but it's a friendly one. I did never thrown. It is just printed, OK? So relax. Relax. Ooh-sa, right? Don't panic. I want to look in this map, in this trace. And this is my runner. I want to also switch here and then figure out that this is the runner at line 64 that calls ops isPrime. And then guess what? My actual method is over here. What the heck is this? Oh, I know. It smells like spring, huh? I can see my aspect here, but what's most interesting is that I can see the caching interceptor running before I apply my aspect. What does this mean? Is that the first call will get through here. The second call will just be served by the cache interceptor. It will never propagate further, and it will never reach my intercepting aspect here. Make sense? So you see, the order that aspects are weaved starts to matter. You have to realize that. And one way to debug it is to just look at the stack trace and see where are you? Where are you? Where are you? Where are you? In the stack trace, OK? Because there can be many things there. OK, good. Wow. Next, things get tougher and tougher. What if I run from within this method? I am in the method in the class which is cached, right? What if I run here this method on myself? Question for you: will this be served from the cache? No. No, but you learn that by suffering, right? Most of us have learned that by suffering. And if you, okay, you all sense a bit of panic now. It's natural. I'll just hide the exception. Just hide it. Huh? Catch and no, never do that. So then, look what can happen now. When I am asking for the prime, I see that it's computing again the prime, although the prime should have been served probably from cache. How do you fix this? There are two ways of fixing that. I will show many more. I will show you just one of them. The problem is that if I call my wife, and if I speak to my wife, technically speaking, no one should intercept that conversation. In theory, okay? In the kitchen, I'm talking to my local method, to my local wife there. No one can interfere. But then what I really need here is to go through the proxy for proxy to give me from the cache. So then AOP context dot current proxy, and I will say this is expensive ops, and then say myself proxied equals. And on myself proxied, I am calling is prime. Wow, what the heck is this? What the heck is this? I'm requesting a proxy to myself, to my current running class. And guess what? This time, when I compute hash files, there is no more computation happening in between. So it worked. Make sense? Good. Now, one more trick to show you. What do you think will happen? Oh, God. Oh, God. If I make this final. You're asking for it, right? I'm just asking for it. And guess what? That one who searches finds. This is untranslatable, I think. But the point is, the computation happens many times, but Spring doesn't complain of anything. It just silently doesn't apply the aspect, the cacheable anymore. Do you see that? Strange behavior, really. I would expect it to say something to me. Nothing, right? Just nothing. Nothing. Just silently ignoring the method because it is final. Make sense? OK, one more. What if I want now to have a lighter version of the cache? That's the last stuff, I promise. So let's create a public bean post processor. Oh, yes. You've been expecting that, right? Cache augmenter, which will return new bean post processor of post process bean. No, not that. So bean import, OK. And this, yes, of course. And then say if bean get class is annotation present for say.class, then log debug wrapping in proxy of bean, and then return class proxy.proxy bean. Else return the vanilla bin, let's say, right? Whoa, what's this? What does this mean? It means that, technically speaking, I don't need to put cacheable nor here, nor here, nor here. This will actually break the, but let's see if it really works. This requires me to go in the class proxy and make it more generic. And as I do that, I realize that I was never actually depending on the actual expensive ops. So I can say bean.getClass. I'm just proxying whatever comes to me. I'm proxying whatever type comes to me. I'm creating the same type again, and I'm returning it back. And of course, we have to put the semicolon there. I always forget that. Nice. So, it worked. Yes, it worked. You can see that it is intercepted this prime, and this method actually computing. The computation never happens here. You see that? So it is served from a cache. But still, if this is true, it means I just got rid of all that stuff that Spring did for me. I need to prove that in the, where are you? Here in the actual class, I will put back the lady in red, the exception, and see what happens. It's the same stuff. Why didn't I get rid of it? If you look close, you can see that there is my class proxy going on there, but there is also my execute around from the intercepting, from my aspect. What really happened is that Spring found out that this method in particular, this one, is marked with logged. And because he knew that log needs to be intercepted, guess what? He created a proxy for this again. How can I fix this? Remove this. If I remove that and run again, guess what will happen? Oh, a shorter stack trace. Good. Faster, right? That was it with live code. Now, let's try to stretch this. I think I will be several minutes over the time. The bottom line is, whenever you don't understand how Spring does something, it's a proxy. Meaning cacheable, transactional, aspect, async, secured, validated, even threads on request scope, session scope, they all rely on proxies. To put this on a slide, when you have a class A which depends through an interface B to another class B immutable, right? You see this in codebase and you expect that at runtime A will depend, you will have an instance of B immutable. But you've seen that it's not quite that, right? Because in between there is someone more. Did you order the, how was the joke? Did you order the cup of tea? Did you order some sugar? I'm not sorry if you, anyway. So the question is, it will just create such a proxy, and basically Spring will give you such a proxy, which implements the interface. We've manually created such a thing with Java Reflect proxy ourselves. But now look what I will do. I will just delete the interface. Look, again. This is not an interface anymore, it is now a class. If it is a class, when you see that I'm injecting an instance of, I'm injecting a class, you will expect for that type to be injected. Surprise, surprise, it isn't. In between, there is a proxy. Now, for basic science, because this needs to be assigned to a field of type B, it means the proxy needs to extend the type B. Basic science. Now, we have also created this stuff manually using CGLIB, using enhancer. Now there will be something very creepy. I warn you. The instance of the proxy doesn't matter. Meaning that if you are using request scope, you might get injected different proxies wherever you put auto-wire, 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 you get 4 proxies. But if you talk to the object through those 4 proxies within a single request, you will end up talking with the same very instance of the request scoped bin. Make sense? What I mean here is that it's a many-to-many relation between proxy and the real implementation. It might be that multiple proxies delegate to the same instance, or vice versa. One proxy can delegate, depending on the current thread, to various thread-scoped bins. I warned you it will be hard, but that's it. Now, quick questions. Can a method of a non-Spring bin be intercepted? What do you think? From what I've showed you until now, doesn't appear like so. So no. Can a final method be intercepted? Technically, no, only if it's a class proxy, but if you are using interface proxies, it can, because it will implement the interface again. Then, can a field access be intercepted? Can you intercept the change of a field? Oh, no, for Christ's sake, no. Can you intercept a private method call or a local method call? We've seen that by just calling that one, no. But then I've showed you some workarounds. But you know, really, actually, I have to tell you, you can do this by hacking the bytecode, either for compilation using enhancement, bytecode enhancement, or at loading time, which is called weaving, which is called load time weaving, LTW. Spring supports that, but it means you are employing heavy artillery. So normal projects don't need that. OK, but still, if you really want to call a method from yourself, from the same class, what will happen? Now, imagine this is the first idea you could get. Let's auto-wire myself. But if you do that, you will end up in this problem, right? I mean, what the heck? Spring will not start. Then you can inject Spring application context and look up myself. Where am I? Or you can inject an object factory to be more specific. I only need myself. But the act of finding yourself is like texting yourself. I'm feeling lonely. Ah, someone texted me. You know, that's weird in a sense. Now, you can you go for lookup method, whatever these are. But what I've showed you is this picker and proxy. Now, this is an example. If you have a method which is annotated with transaction that requires new, well, each time you will get to this method from outside by calling through a proxy. That proxy will start the transaction for you. But if you call the same method from within the same class, that new transaction will never start. This is how those guys here learned this by the hard way, probably. This is how I learned it. Oh, there is no new transaction. Why? You know? So what you could do is that to get a proxy of yourself, and then what you're effectively doing, you are getting a call through the proxy explicitly. But the point of IOP was to be invisible for the developers, was to be completely transparent. But as soon as you request the aspecting of myself, the magic is over. Exactly. Bravo. The magic is over. Yes, no more magic. But then, wait, it's not done. I'm not done. I have 1 or 2 more hours. So. One alternative I could show you is the functional programming. If you have save page and you want to measure how much time the save page takes, look what you can do. You can wrap it in a lambda and pass it to another method. Make sense? This is actually what you usually call execute around. So you have a function already, but you build another function within which you want to run the previous function, to measure stuff, to start a new transaction for that method. This idea was already there decades ago, but it is now, since 6 years ago, it's super easy to do with method references or lambdas. So it's just syntactic sugar for the same stuff. Good. Now, remember this stack trace in which we were searching for our own code? How good this feels, right? When we are looking at the stack trace, where is my code? So, this, here, and there. You know what I call this? This is a hamburger, friends. Why? Because look, I found my code. And the next question you ask yourself, what's the other stuff? And why I call it the hamburger is that, are you sure you want to know what's there? Really? That's why I call it the hamburger problem. But the answer you know, right? There are proxies. There are things that intercept your method calls, right? OK. But then let's see. Imagine now you are creating your own aspect, and you want your aspect to communicate with another aspect that runs several layers down below the call stack. How can you pass data from one aspect to another? Ideas? How can you have aspects pass themselves data? If they are invisible, this is a hard question. Does this help? What is shared between throughout an invocation? The thread, exactly. It is the same thread who executes the code from that method, that method, that method. So then you will pass logic between invisible logic. You will pass data. Actually, you will have invisible logic communicate via invisible data. Magic. Be aware of that. Things can go rampage. Things can go bad. In case you switch threads and you run on an executor, on a sync, thread data will get lost, so you have to propagate the thread data from one thread to the worker threads. Hunt me down to show you code about that. Now, several leftover advices about building your own aspects. Make them visible. Not all of us, not all of our team is aware of those aspects, is continuously aware of those aspects. So make them visible. For that, I would always recommend to do annotation-based weaving, meaning that I want to annotate all the methods within the facade class. Or maybe even better, within a method which is annotated with logged. Be more specific. Put it in front of the developer's eyes. It is logged. Look, it's written here. Logged. You know? That's the idea. Make them visible. The alternative would be to have them on some convention on package names. These are the facades, right? Or by class names. You need to know these conventions. Otherwise, you will get in deep troubles. So prefer to have annotation-based weaving for your methods or classes. Another idea, keep them light. don't start sending HTTP messages or GMS messages from your aspect. Because since it's sometimes invisible for in the developer's mind, if they are too heavy, can hit on the performance part. Interesting. And even if you keep them light, if you intercept methods which are called 1,000 calls per second, it will start to matter, right? So don't intercept insane rate calls like I did. Don't do that, because then you have to search for alternatives. One way to do it is this good old copy-paste programming, of course. I mean, let's realize, it's still an option, right? Copy-paste code everywhere. Another alternative would be the execute around. Just have on-demand aspecting of a method by wrapping it within another call, like measure, remember? Measure of save page. Or a third one would be to go for bin post processor. A bin post processor is something that sits in between the creation of an object and the time it is placed in the container, in the Spring container. What's happening there? If some way or another you create an instance of a bin, then you auto-wire it and then you post-construct it. Around the post-construction phase, there can be bin post processors doing stuff with your instance. Maybe even returning different instances. And guess what I did? Remember, I returned a different instance, a proxy, right? This is exactly what I did. And I ended up putting in my container a class which is actually a proxy of the real implementation. But this is somehow bypassing the Spring AOP standard, the Spring standard AOP mechanisms, because I'm doing this aspecting by my hands. Why would I ever need to do that? Because I don't like all that I'm given by Spring, and maybe I just only want just one little tiny healthy piece of that. Green piece of that. Green piece, exactly. Okay, now of course you all were expecting for performance. Huh? It's obvious that's cacheable with all that hamburger stuff. It's way, way slower. Now, folks, this is not to talk about performance, it's to talk about design. You can check out the Git there and try it yourself. I'm not entirely, sorry, this is not a study I've run for 2 months. This is something I've tried several days. But I kind of expected the results. As you can see, whether you have a method which just delegates to another local method and has the cache, whether you have Decorator, another class, whether you have instance or class proxies wired via bin processors, they all behave kind of the same, right? The drama is when Spring comes in with its own. But folks, I don't mean you should burn Spring away and you should reinvent the wheel, please. I'm just telling, for those cases in which you want super, super fast responses, think maybe for other alternatives. Other tricks for which I am more than willing to be hunted down after the talk. Double proxying, what the heck is that? Aspect order, sharing the persistence context. If you are intercepting a method that runs with GPA and starts a transaction, your question should be, am I running in the same transaction as the method that I intercepted or not? Hardcore stuff. Then proxies are always in ORM, are also in ORM, in Hibernate. Now, again, every time I don't understand how Spring does something, it's a proxy. I had one more slide about mixins that I really like to show you, but it will keep you for 2 more minutes, I'm afraid. So all the food will be gone until you exit the room. Okay, let's do that. Spring data. Who of you knows about Spring data? Raise your hand. Spring data, good. Now, you have this customer repository, so fast forward. Customer repository, which has methods by convention, has query methods on themselves. It extends from a GPA repository from Spring, and it can also extend from your own interface, which has the methods for which you need explicit manual implementation, like typing code, you know? So for that, you will have by convention a corresponding implementation. You can also put it within another base repository to add some methods to all your repositories at once. You only need to implement them once, and all of them inherit them. But then comes the interesting part. When you inject the customer repository, what will happen? You will get injected this is an interface. You will get injected a proxy. And the proxy, depending on the method you call, it will dispatch to the corresponding method that you called. It's a sort of a gateway, a multiplexer, a Spring that dispatches your calls to different places. Then, key points. Proxy, we've covered Proxy and Decorator design pattern, actually. And I've showed you different ways of wiring decorators. Profile stuff, qualifier stuff, interesting. Then we've manually created interfaces and class proxies, so you can understand what's under the hood of Spring. I've showed you several tricks how to debug and how to work with Spring AOP, like current proxy, like seeing it, analyzing the stack trace. And I also gave you several advices of how to do custom aspects, like keep them lightweight, use annotation-based weaving, and so on. But the idea is, I don't advise you to go astray or reinvent the wheel. Stay on mainstream. Keep it simple. Keep it short and simple. But understand what's under the hood. And in case you ever have a problem, think if you need and if it really works to get out of the mainstream approach. In short, the performance problem will not be there. 99.9999 cases, the performance problem is not in your aspect. It's in your database interactions, in your external systems. Thank you, all of you, for having me here. Have a nice spring. And in case you have any kind of questions, I'm more than willing to chat. If you want some posts, do follow me. And the best part, I brought you some stickers. Yes, because in our profession, the culture is based on stickers. So come get some culture. That's it.